Greetings, ladies and gentlemen. So we have a shark 3D model right here with all the textures, with all the little features that it's got. And all these textures are not going to matter for this demonstration, but I'm here to show you just what it looks like. So this is the Autodesk Mesh Mixer software. It's a collection of tools, what it is. And then you have all of the analysis software. You can close any of these missing components. You can do an inspection like this, and then you can repair everything on this 3D model if it needs to be repaired. And you can also do some editing here like this, and you can also use this to close cracks if there's any kind of cracks in these polygons that make up this 3D model. So all of this is here. It's available from Autodesk Mesh Mixer, and you can export it as an STL format, OBJ, and all of these other variations of file formats. And then you can save it into a file, your folder, as you like. So that's where we're at. But you can come here to, if you want to know where to find it, you come here to Google search and you just say Shark 3D model, and then this shows up. You can see here in purple, these are some of the sites that I visited, and then a couple of here, and then one more, which is where I got this Shark 3D model. This one's from Ridge Models. And then I looked here, it's all the different sharks that are available online and other pages as well. So different variations. You can come here, and in this case I chose this particular shark. So you can probably recognize it now. It's got all the texture, familiar texture, and all the shapes. And according to this, there are approximately 4,380 faces. You can download this for free. It's available from this website. Of course, there are also other libraries of 3D models available for different sharks. There's a bull shark. There's a turtle here as well. Oh, nice. I didn't notice that one before. Anyways, there are various different kinds of 3D models you can design, and you can upload them. You can also download them, as shown here. There are loads of them, but that's all it takes. I'm just showing you where I got it from. And we can come here, and after we download it and saved it into a file, into a folder, we can actually take it over here and import it into this thing called SimScale. SimScale is one of a handful of different kind of computational fluid dynamics simulation platforms. So this one is available on the cloud for free of charge, costs no money to you. To the user, it's free. And basically, we have to get to this point where we have a fluid flow around a 3D object like this. There are a series of steps that one has to take. One, of course, is double checking for the meshes. So in this case, there are meshes. We are aware of those meshes, and you can also double check with the Autodesk Fusion 360, make sure the meshes are present. That's it. And then once we import it into this software here, there's a button here. It says import geometry. Once you import this here, it'll ask you to select from different file formats that are compatible with this CFD software. So once that is done, you go to here, this Cad Mode. So the Cad Mode is just a way to do post-processing and editing, scaling, further scaling, refining of the 3D model here. So in this case, what I've done is I've taken a 3D model, I created a shape, and this box here, this giant box that's around the shark, that is actually the fluid volume So the fluid is bound within these walls. So the box here is a boundary for the walls, which will be filled with a fluid that is calculated by the cloud computer. There are algorithms for this that are specific, and they're noted on here as far as simulation control and perhaps some of the boundary conditions as well. But you can come here, and once you create this box in the Cad mode, then that is where we begin to create this CFD model around an object. So here you can see the box, and here on the left side, the history tree. There's a list of items in chronological order from top to bottom, which an object was created and then, or imported rather, and then scale down. So I scale down the shark here, and I can change the render mode here to show what's inside this box. So you can see here the shark, the shape of the shark is present within the box. And that shark, I created a hollow section or a hollow region of this box, which will serve as a wall. So even though it is a hollow piece inside of here, and that is the shape of a shark, that is the purpose of that is just to create a wall that is specifically shaped like the shark, and that wall is a boundary in itself, is a type of boundary, so to speak, and that can be shown here, right here. So this external flow volume, it comes from this icon here: flow volume, external, internal caps. So for our purposes today, we have the external volume, and you can actually change the shape of the volume. Not necessarily the shape, but in this case it's a box, but we can change the dimensions of the box itself. So once that is defined, here are the dimensions I use after scaling the shark. So I wanted the shark to be roughly about 2 meters. When I imported it, it was roughly about 150 meters. That is a giant shark. But I want 2 meters, so that's what the scale function is for. You can scale it down, make it the right size. Anyways, so once you do that, you do this thing called delete bodies, and the delete bodies function allows you to select an object. So in this case, the object that I had selected was this shark in the center. So what I can do actually is select these faces here like this, and I can hide these faces. So once I select all of the faces on this box, I can actually right-click anywhere in this open white space, and I say hide selection. So once I get to that point, I actually can. Wait, hold on. Let me see here. Normally, I would be able to select the boxes. You get the point, and hopefully you get the point actually. But once you select these boxes and hide them, then you can use this active box selection here to select the shark, and then you can delete that body. I think the reason why it's not working is because I already deleted it, but that's what would happen. So once you get to that point, then everything is good to go. So we created a hole here in the center that is the shape of the shark, and then the rest of this is just a flow volume. So those are the prerequisites for creating this 3D model. So now that we have this shark shape inside of here, we also need to be able to see it really well. So we double check here the render mode, and then we have to change to the translucent surface. And then there's a wireframe surface if you want to use. There are also surface, and then just the pure wireframe. But in this case, I happen to prefer translucent because I can see through it, and I can see the shape of the shark. But the box is still there. It's clearly visible. So once all this is confirmed and you say, okay, this is what I want to use, then you would come here and do the simulation, which is the next step. So the simulation, I click on this plus symbol, and it shows a list of different kind of simulation tools available. There are structural simulations and there are flow simulations. So in this case, we go by the default, which is the incompressible fluid flow. Because, well, water is a kind of liquid and it's incompressible. So we can click on create simulation. Normally I would click on that. However, this has been done. I've done this for us already, and it shows all of these parameters here that can be tweaked and tuned to your liking. So in our case, there are default values that are set already, but there are certain things that we need to actually change. So all of these here, they can stay their default values. So we don't have to bother with any of these because that's what we want. And then the geometry itself is just, we select this volume here, and once we click on that, you see like there are three sections here. Like there's the original imported design and then the modified design with the box. So we actually want to select this one to do a fluid dynamics simulation. And then I want to fill this box, this fluid volume, with some kind of liquid. I need to select it, so this will highlight here, flow region. And what do I want to fill it with? I want to fill it with certain kinds of material. When you click on, okay, hopefully you saw that. When I click on this plus symbol right here, it will show the different materials that are available by default. There's air, argon, different kind of gases, oil, and water here as well. You can also pick salt water, seawater here, and then these are the default values that are defined. Okay, so for our purposes, since it's a shark, many sharks, they live in seawater, so it's only natural that I've selected seawater here. And then the initial conditions, we can leave this. There's no need to modify this in any way. Everything is good. So these are the default values. You'll see these check marks here showing that everything has been set. And then here, the boundary conditions. The boundary conditions it's just a way of selecting which inputs and outputs do I want. So if we consider this box as a square tube, then if we can imagine this as a square tube, then we can treat these walls below, above, on the side of the shark as a wall. So that's what I did here. When we click on this plus symbol here on the left side, we can select wall, and we can assign that wall. In this case, I assign the 4 walls here, this one, and the other 4 around the shark. This one as well, and all of these others. Just these 4 walls, like this. Excluding the walls that are in front and the wall that is in the back. Exclude these because the front wall that is in front of the shark and the back wall that is behind the shark, these walls will be the input and output of this quote-unquote square tube. So we save this, and then we say, what is the pressure inlet? The pressure inlet, in this case, I selected this as the pressure inlet. And then this is a value you can choose. You can change, play around with these parameters here, whichever you see fit. But in this case, we are using megapascals. And then we have a rear wall, which we need to select, and then that is the pressure outlet. So in this case, the pressure inlet is a fluid flowing toward the shark from this side of the square tube. And on this end of the square tube, you have fluid coming out. So that is the pressure outlet. You don't need to make this some other, you don't need to add any pressure to this. It's not necessary. You can if you want, but for our purposes, 0 pascals is just fine, because out here is just an output and the fluid is coming through here, through the front. So the fourth, we actually need to create a fourth wall. It's a different kind of fourth wall. Actually, it's a second, technically it is a second wall. Hold on. Essentially, there is a shark here that is hollow, and in order to select that wall in the center, we actually need to hide all of these walls here. So once that is hidden like this, we select the walls manually, click on each of these walls and hide them. Like I said, when you make a right click on any of these white edges around the box, this squared tube, you could say hide assignment, or wait a second, hide assignment, wait a second, hide selection. It would say hide selection. It's not showing right now because I already hid the box. That's the thing. So normally you would select the walls like this, and then it would say hide selection. That's what it would say. But in this case, I can hide this like this, and I can select the shark. See right here, the shark is considered a flow region. It's assigned a face number, face 91. So here's a shark. That's been hollowed out of the box, and we can create a slip. We can create a slip wall. So it says here, the boundary wall condition subtype base wall movement. In other words, this is something that is going to be treated as if it was a solid. So that means when I have fluid that's coming in through the front of the shark, then of the shark's 3D model, then the fluid will actually flow around this 3D model here. So that's how we get to this point. So those are the boundary conditions. We have already set those here, and there's no more need to modify any of these components regarding the 3D model, because we've defined the boundary conditions, the inputs and outputs. So all that is done and taken care of, and now the next thing we actually need to do is look at the numerics here. There are many parameters here you can change and tweak, but these are default values which we do not need to change. It's not required. However, if you feel like there's something that you have to change, that you want to create here, then you can do it. But for our purposes, there are no requirements of changing these numerics here. And then the simulation control here, I've selected 20 seconds with a right control set to the runtime. Sometimes by default it would show the time step, but in our case we need the runtime. There are other parameters here that we could select, but for our purposes the runtime is what we're going to need to do this 3D model, this CFD analysis. So the runtime is a maximum of 30,000 seconds, and we can select the right interval of 1 second. And then we also need to check this. This is by default. By default, it is off like this, and we need to turn it on like this. Now, all of these parameters right here, that's what we need. So have a good look at this. Pause the video if you need, and we can move on. So that's what we have, and then we can go to the result control. There's nothing to change here. None of these needs to be modified, so we'll keep that as a default. And then the mesh itself is what we use to create this CFD calculation. All of the boundary conditions that are defined, this mesh will create these geometries, these polygons, around the shapes, and then the calculation will be based on each of these cells here. So we can change the algorithm between these different three, and for our purposes, the standard is fine. You can also choose the hex dominant for very fine features like microfluidic 3D models. That's also available. And for our purposes, we're doing on a rather large subject, large object, a shark. So we're just going to do standard. And the sizing, we'll keep it automatic. The fineness or the coarseness of the mesh, we'll set it to 6. So I've done it here already. And then all these other parameters here, these are default. So this is good. So you can save these settings here, and we'll move on to the next step. What we need to do next is actually create a, wait a second, there's no need for a region refinement. Region refinement is totally possible. You can experiment with smaller boxes that are within, you can create smaller boxes within this fluid flow volume in order to play around with the fluid flow, and then see how many small features you can get, and how many kind of calculations, how much better the calculation details will show within the smaller boxes inside of this fluid volume. So that is up to you. In this case, we're not going to use it for this experiment, so I'm just going to turn that off. It's not necessary. But once we get to this point, once we've generated the mesh, and we say generate the mesh, then you'll see a box here on the bottom. It'll say mesh, create a mesh, and then you select that. It'll calculate how much time it takes to create these 3D shapes. So in our case, let's again choose a translucent surface so that we actually can see the shark in the center here, and that way we don't get lost. So let's do that here. Face, long. All right, the rest is good. Now, what we can do is leave the rest of these shapes here, the rest of these parameters alone. We'll keep them by default, and then we can run a simulation. So simulation, we just press this green, we press this plus symbol here, and it will calculate for us how many calculations can be done and how long the calculation is going to take. And in this case, I've done 10 simulation runs, and we're going to get it's going to refresh and renew itself again after this run. So normally you would press start here, and the simulation will take a couple of minutes, and then you just have to sit here and wait. So in our case, we've already done that. I've done that for us, and we can actually come over here to the simulation run and do the analysis. So this is what the simulation looks like after everything is done. We press process results like this, and then we have to come over here and we have to select different parameters to achieve this result here. So in order to actually achieve this right here, we have to select the box on the outside, and then the box has to be hidden, and because if we show everything, the box will show like this. Look at this. There'll be a box that's in the way. You can't see what's inside of it. So this is not very useful. This is what you will see after immediately opening the solution results, the simulation results. So in order to see what's going on inside the box, once again, we will select these faces here like this, and select this one, and select this face here, and this face. and we need to hide these. And then we need to hide this one more face here, and right click. Again, we have to right click it here on the side, and then say hide selection. Now we are left with the 3D model that's been created on the inside. So how do we get to this visualization right here in front of us? In order to get to this point, we actually need to select the color. What color is this box or this 3D shape here? And we can select a solid color. We can change it to pressure, so like the pressure is being shown on the shark itself. We can also select the velocity magnitude to your desire. That'll show what's going on the surface of this 3D model shark. So that's what we have here. Actually, I just realized I should put this on full screen. Okay, that's better. So now we have this going on. We can actually see that there is a... Okay, let me go back out of full screen. I think it's more convenient if I just do this here. Okay, anyways, back to what I was saying. We have this 3D model here of the shark, and then we have the opacity. We can change like how transparent the shark is. We can change it all the way to the left and right. We can change the turbulent kinetic energy that is around the shark, as well as the all of these other parameters here. So in this case, I chose a gray, just a solid color, because it seemed very fitting to me. So make sure that's on. And then the cutting plane itself right here, this is, we can keep the default values here. We can also move the... Okay, there's a switch here. Normally it would say clip model when you turn it on. When you first open this filter, it's cutting plane 1 filter, but we don't want to clip the model. There's no need to actually slice or remove this 3D model out of the way. So you have to make sure this is off, the clip model here on the left. And then all of these others, they will be by default. So let's keep those. And then we also need to click particle trace. The particle trace is right here on the upper left side, upper left hand side. And once we click on this icon, it will actually bring up this particle trace 1. And the parameters for this particle trace 1, in my case, you can see here, I can change the width of these purple dots here in the center. So these purple dots just indicate the position of which you have fluid coming in front of the shark. So I changed this to 14 by 8 or 8 by 14, and I can change the spacing between that. I can change it this way, like this. I can change it, make it even smaller and more concentrated, like so. You can see that I can make it this small. Whatever it is that your heart desires, you can do that here. It's possible. So you can see that here in real time. So you can do that, and if you want to change the position of where the particles are coming from, you can click on this dot right here, and that will allow you to actually select which area. Do we want to select up here? Do we want to select up here? Down here by the fins? You can select the position, change it however which way you like. And we can also change the representation here. We can change it into little particles, like so. Little spheres, we can change it to tiny little comets, like so. And there are many possibilities here. But in our case, I think we can choose whatever it is we want. You can also change the pulses, like so. The number of pulses that's happening. You can also change the length of the comets, like this, very easily. We can change the size of it. I prefer a smaller smaller iterations or smaller particles, smaller lines, just so it's easier to actually see the shark. So that's what's going on here. So here we go. You can see this 3D model of the shark. We can trace both directions. So you can save these parameters if you want. You can take a screenshot. You can write these down. Pause the video. It's up to you. But this is what works for me. And then what I need to do is select animation. So there's an icon here that says animation. And I've already selected the animation, but for you, if you're starting, you can select animation here. And then you can select what time do you want the animation to start from. So I selected 1. And we can end at the last iteration, the 20th one. And we can also select this button here. It says play. And then when we do that, it will start to compute the particles flowing in front of the shark. And then you will begin to see the actual animation of the fluid flowing around the shark from the first iteration all the way up to the 20th iteration here. You can see on the right. So now we have successfully created a 3D model of a shark that we converted from an online, downloaded from an online library, and then we use that to create a computational fluid dynamics model. We simulated it, and now we can see the fluid flow and how aerodynamic an object is. So we can see the shark here and how aerodynamic it is. So if we choose to change these colors, we can provide a legend here. Select this, and then we can change the pressure, how that is represented, the velocity, magnitude, and all these other parameters here. But I think it looks clean without the legend for now. And we can see how everything looks this way and that way, toward the rear, how well the fluid is flowing around the shark. So I'm going to play around with this a little more. I'm going to say I want spheres. I want there to be more of them flowing around the shark. A long trail of tiny little spheres that look like actual particles flowing around the shark. Look at that. Now you can see what looks like little particles flowing into the mouth of the shark. You can see here that the shark's mouth is actually open. So it almost seems as if the shark is smiling, and you can see the front view as well. Look at this. So let's see what else we got here. So normally, like I said, I would select the cylinders. This is pretty default, and this is how these are my parameters for the cylinders. And then I would just select save. That's good, and then let the animation do its job. Now we can have a nice look at the fluid flow around a shark. So this is a 2-meter shark. This is a life-size shark 3D model. Anyways, well, I hope you enjoyed this demonstration here today. There are some others that I would like to show sometime in the future, but this is what I have for today. So thank you all for coming, and feel free to try out some of these simulations yourselves and take some hints from here. Hopefully this was helpful and some learning experience, something interesting for you to see. All right, ladies and gentlemen, thank you for tuning in. Take care out there.